There's a photograph that no longer exists, at least not in any official capacity. It was taken in rural America somewhere in the early 1900s, in a place where bloodlines folded back on themselves so many times the family trees looked less like trees and more like tangled vines. In that photograph was a pregnant woman. Local records listed the father. But here is what those records didn't say, what they couldn't say, because the truth was too grotesque for a time that preferred to bury its secrets. Her husband was also her son. This is not folklore. This is not some campfire urban legend. This is documented history. What you're about to hear is the story of the most inbred woman ever medically recorded in the United States. A woman whose DNA became a closed loop, whose children were nothing but genetic echoes of a bloodline that should have ended generations before her birth. Time has taken her name, or perhaps it was deliberately erased, but her genetic profile remains. It still sits in medical journals, a biological horror story written in chromosomes and recessive genes. And tonight, we are going to tell you precisely how this came to be. Hello everyone. Before we begin, make sure you like and subscribe to the channel, and leave a comment telling us where you're from and what time you're watching. That's how you tell YouTube to keep showing you stories like this one. Now, let's go back. Back to a time when certain families didn't marry outside their communities, not out of tradition, but because it wasn't an option. Back to isolated valleys and mountain hollows where the same surnames appeared on both sides of every marriage license. Back to a place where doctors would whisper about things they'd seen but would never dare to record. Because this woman's story didn't start with her. It started decades earlier, with a family that made a choice. A choice that warped and twisted through the generations until it produced something that should not exist in nature. By the time she was born, the damage was irreversible. The question isn't merely how this happened. The question is how long it had been happening before anyone noticed, or before anyone dared to speak it aloud. To understand how a bloodline could collapse in on itself so completely, you must first understand the landscape that allowed it. We're talking about Appalachia in the late 1800s and early 1900s. Not the romanticized movie version, but the real thing. Valleys so deep and narrow the ground only saw sunlight for a few hours a day. Settlements separated by ridges so steep a journey to the next hollow was a full day's walk on foot. In these places, the outside world wasn't just distant, it was irrelevant. Here, families didn't just live near one another. They lived with one another inside a web of relationships that had been tightening for generations. The Fugits of Kentucky turned blue from methioglobamia, a genetic condition that only appears when the same recessive gene comes from both parents. The Whitakers of West Virginia became a modern example of a family tree that refused to branch. But the woman we're discussing today came from a line that went further than any of them. Medical researchers who later studied her case under strict anonymity discovered something that should not be genetically possible in a living human. Her coefficient of inbreeding, the mathematical measure of how much of her DNA came from shared ancestors, was higher than that of laboratory mice bred specifically for genetic uniformity. In some parts of her genome, she was more inbred than purebred dogs that can barely walk or breathe without help. How does that happen? It happens through a cascade effect over multiple generations of marrying their own relatives. First cousins marry and have children. Those children grow up and marry their own first cousins. Then their children do the same. With each generation, the gene pool shrinks. Recessive genes, the ones that normally hide in the background, start pairing up, and you eventually reach a point where a family is essentially breeding with itself. But even that doesn't fully explain her case, because the record suggests something darker. Something that went beyond the isolated practices of mountain communities. The genetics told a story the family histories tried to hide. This wasn't just cousin marriage over time. This was closer, much closer. And it had been happening for so long that by the time she was born, her very existence was a biological impossibility that had somehow survived. The land kept these secrets well. Mountains don't talk. The neighbors didn't either, because they were family, too. Her grandmother married her uncle. That's where the paper trail begins to fracture. County records show names crossed out and rewritten, dates that don't align, birth certificates that list fathers as unknown when everyone in that hollow knew exactly who they were. But the genetic evidence reveals what the documents tried to hide. Her grandmother didn't just marry a close relative. She married someone who shared so much of her DNA that their children were born with the genetic diversity of siblings from an already inbred line. Those children grew up in a world where normal didn't exist, where the concept of outside blood was foreign, perhaps even threatening. In isolated communities like this, marrying outsiders wasn't just unusual. It was sometimes seen as a betrayal. It meant bringing in someone who didn't understand the ways, who might ask questions, who might see things that were meant to stay hidden. So, the family doubled down. They married each other, again and again. By the time her mother was born, the damage was already catastrophic. Medical records from that era that survived described children born with physical deformities doctors had never seen. Facial features that seemed to melt into each other, malformed limbs, cognitive disabilities so severe some children never learned to speak. But some survived, some grew up, and some had children of their own. Her mother was one of them. And the man her mother married, if you can even call it that, was her own son from a previous relationship. Not a stepson, not an adopted son, but her biological son. The genetic analysis confirmed it beyond any doubt. The woman we're discussing was the product of a mother-son union. But that isn't even the full horror, because her mother was already so inbred she was essentially the genetic equivalent of her own cousin. Think about what that means. Every human gets half their DNA from their mother and half from their father. But when your father is also your half-brother, and your mother is already the product of multiple generations of inbreeding, the math breaks down. You end up with massive sections of identical genetic code appearing twice. Recessive genes that should show up once in a million births start expressing themselves in clusters. The body tries to build itself using a blueprint that's been photocopied so many times the instructions are illegible. She was born anyway. Against every biological probability, she survived infancy. And as she grew, the family continued on as if this was normal, because in their world, it was. The outside world didn't learn about her until 1978. A young doctor doing rural outreach in an unnamed Appalachian county came across something during a routine medical examination that made him stop cold. He'd been sent to these remote areas to provide basic health care to families who hadn't seen a physician in years, sometimes decades. He'd already encountered malnutrition, untreated diseases, and conditions that belonged in 19th-century medical textbooks, but nothing prepared him for what he found in that hollow. She was in her early 20s then, small, with features that seemed slightly off in ways that were hard to pinpoint at first glance. Her eyes were too close together. Her jaw was misaligned. She moved with a hesitation, as if her body wasn't entirely sure how its parts were supposed to work together. But she was pregnant, visibly, unmistakably pregnant. The doctor asked routine questions. How far along was she? Did she know when the baby was due? And then the question that changed everything, who was the father? The family went silent. That particular silence that falls when a secret kept for generations suddenly threatens to surface. Finally, someone spoke. A relative, an aunt, maybe, or a sister, the family relationships were impossible to untangle, pointed to a young man sitting in the corner. Her husband, they said. The doctor nodded, made a note, and almost moved on, but something nagged at him. The way they'd hesitated, the way no one would make eye contact. He came back a week later with a county health worker. They asked more questions, gentle at first, then more direct. They took family histories, drew out a genealogy as best they could, and that's when the structure started to emerge. The same names appearing over and over, marriages between first cousins, second cousins, uncles and nieces. But even that didn't explain what he was seeing in this woman's physical presentation. The signs pointed to something more extreme. Blood samples were taken, not forced. The family was surprisingly cooperative once they understood this was medical, not legal. Maybe they were curious, too. Maybe some part of them wanted to know what they'd created. Those samples were sent to a university genetics lab with a note that simply read, "Please analyze for consanguinity, possible extreme inbreeding case." The results came back 6 weeks later. The geneticist who processed them called the doctor personally, his voice on the phone shaken, all professional detachment gone. "Where did you find her?" he asked. "Because what I'm looking at shouldn't be alive." The numbers told a story that defied medical understanding. A normal human shares roughly 50% of their DNA with each parent, 25% with each grandparent, and about 12% with a first cousin. This woman's genome showed homozygosity levels, sections where both copies of a chromosome were identical, exceeding 42%. To put that in perspective, children born from brother-sister incest typically show around 25%. Children of parent-child incest can reach 37% in the most extreme documented cases. She was beyond that, significantly beyond. The only way to reach her level of genetic uniformity was through multiple generations of the closest possible inbreeding, culminating in a mother-son union where the mother herself was already severely inbred. Her DNA wasn't just doubled. It was layered, folded, compressed into patterns geneticists had only seen in controlled laboratory experiments with fruit flies and mice, experiments designed to study genetic diseases, experiments where most of the subjects died. But she was alive, walking, breathing, pregnant. Her body had somehow navigated the genetic minefield that should have killed her in the womb or in early childhood. The researchers found she carried homozygous recessive genes for at least 14 different severe genetic disorders. Normally, any one of these conditions would be catastrophic. Cystic fibrosis, sickle cell markers, multiple metabolic disorders. Her body was expressing some of them in mild forms, chronic health problems she'd lived with her entire life, assuming they were normal because everyone in her family had similar issues. The pregnancy complicated everything. The doctors knew, though they couldn't say it directly, that the child she carried had almost no chance of survival. If her husband was truly her son, as the genetic evidence suggested, that baby's coefficient of inbreeding would be even higher than hers. The researchers started using terms like genetic load and mutational meltdown. These were concepts usually applied to endangered species on the brink of extinction, not human beings in modern America. If you're still watching, you're braver than most. Tell us in the comments what you would have done if this was your bloodline. The family refused all genetic counseling. They refused explanations about what the tests meant. When doctors gently suggested she receive specialized prenatal care, possibly at a hospital equipped for high-risk births, they simply stopped answering the door. The researchers were left with their samples, their data, and a profound ethical dilemma. They had documented something unprecedented in human genetics, but publishing it meant exposing a family, a community, maybe an entire region to scrutiny they never asked for. The study was eventually published in 1983 in a specialized genetics journal with all identifying information removed. It's still cited today in medical literature about the effects of extreme consanguinity. The woman herself was listed only as Subject F. No location, no photographs, no follow-up. But the data remains, a testament to what happens when a bloodline runs out of places to go. What happened to the baby is not in any official record. The research paper ends with her pregnancy. The county health department's files from that period were destroyed, either through routine purging or something more deliberate. The doctor who discovered her case left rural medicine 2 years later and refused all interviews about his time in Appalachia until his death in 2004. In his personal papers, donated to a medical archive after he passed, there's a single handwritten note dated November 1978. It reads, "Baby F delivered stillborn. Multiple abnormalities incompatible with life. Family refused autopsy. Mother survived." Survived. That word carries a weight. It suggests something was uncertain, that survival was noteworthy in itself. The genetic researchers who studied her case had predicted any pregnancy she carried would likely self-terminate. Miscarriage rates in cases of extreme inbreeding approach 90%. Of the 10% that make it to term, most are stillborn or die within hours. The human body has safeguards, ways of recognizing when something has gone too wrong to continue. But for her, this wasn't the first pregnancy. Medical records indicate she'd been pregnant at least 3 times before. No living children. Each pregnancy ended the same way, stillborn, or death within days. Yet, she kept trying. Or perhaps the family kept expecting her to. In communities like hers, a woman's value was often measured in children, in continuing the family line, even a family line that had long since twisted into something unrecognizable. The researchers later theorized that she herself was likely infertile in any meaningful sense. Her body could conceive, could carry a pregnancy to term, but the genetic load was too severe for viable offspring. She was, in effect, the end of her line, a biological dead end produced by generations of genetic consolidation. The family tree that had been collapsing inward for decades had finally collapsed completely. But here's what keeps appearing in the margins of those archived documents, in the notes that weren't meant for publication. Rumors of other families in adjacent valleys with similar patterns. Whispers among rural healthcare workers of cases they'd seen but never reported. One nurse's testimony mentions examining 3 children in a single household who all showed signs of severe inbreeding, their mother unable or unwilling to say who their fathers were. The implication was clear. This woman wasn't an isolated case. She was simply the most extreme example that happened to be documented. How many others were there? Living in hollows with names that don't appear on any map. In families that had been folding in on themselves for so long that outsiders didn't even register as human anymore. How many bloodlines had reached their biological terminus without anyone from the outside world ever knowing they existed? The researchers wanted to go back. They wanted to expand their study to understand the full scope of what was happening in these isolated pockets, but the funding dried up. Or maybe it was pulled. These were questions certain institutions didn't want answered. Stories that reflected poorly on decades of governmental neglect of rural America. So the file was closed. Subject F disappeared back into the mountains, and the silence returned. Subject F was last documented in 1984. She would have been in her late 20s. After that, nothing. No death certificate, no census records. She vanished from official documentation as thoroughly as if she'd never existed. The genetics journal that published her case has been digitized, but the original tissue samples were destroyed after 10 years. What we're left with is data without a face. Numbers that represent a human being who lived and suffered in ways most of us can't comprehend. She was born into a genetic trap set generations before she existed. Her fate was sealed by ancestors who couldn't have understood what they were creating. This is how these stories end. Not with resolution, but with erasure. The most inbred woman ever medically recorded in America becomes a footnote in a genetics journal, a case study that medical students memorize and forget. Her humanity disappears into the gap between what was documented and what was lived. But we tell these stories not to gawk at the horror, but to remember they happened, that they were real. That somewhere in America, in living memory, a woman carried the genetic burden of generations of collapse and then disappeared without a trace. She was pregnant, and her husband was her son. But that's not where this story begins. It begins with isolation, with communities forgotten by the outside world until normal had warped into something unrecognizable. It ends with erasure, a woman whose name we'll never know, whose grave carries no marker to tell us she was ever here. The mountains keep their secrets, but we don't have to. Remembering is how we make sure it never happens again. If you made it this far, leave a comment with where you're from. Tell us if stories like this exist in the hidden corners of your state's history. Thanks for watching.